All right, we are given a situation where we have a box on a slope where slope angle is theta. We have a friction force, which is mu. It says we have a velocity that goes up that way, and our velocity is constant. Nope, messed that one up. Velocity has to go down because I said so. So our velocity is constant. Now it asks us to derive for mu. So first thing we're going to do, checklist, create a free body diagram that is labeled. So the only forces acting on this right now, first of all, force of normal is perpendicular to the surface. So force of normal goes up that way and never goes down through. Like you wouldn't see a force of normal that goes this way because that's not how normal forces work. Force of gravity is always straight down. Force of gravity goes straight down. Now, force of friction is always parallel to the surface, which means it will run along this line, one of those two, and opposite the direction of motion. So our motion is going down, friction goes up. So let's erase this portion. Force of friction. Now, those are the only forces acting on this because it doesn't give us a force applied, so we only have 3. So now what it asks us to do is set our axes and positives and negatives and split the necessary forces into the x and y directions. So a majority of our forces are already in the directions where they go like this, and they are already on this slanted path. So we're going to also have it be a slanted path, also just because it's easier to do that when you're working with slopes. So I'm going to set the direction of motion where positive is. So our positives are going to be this way, and then up is going to be positive, our 2 negatives are going to be that way. Just because that makes math fun. Now we will have a negative here, a positive here, and then let's split this one up like the directions told me to. It splits up this way. Force of gravity in the x, force of gravity in the y. Now, where theta goes is right here. This is our angle theta because it's always attached to our dot in the mass. Now, let's label which ones are positive and negative here because now they follow this scheme. Force of gravity y goes down, that's negative. Force of gravity x goes this way, so it's positive. Now we can use our positive and negative forces to set up our force equations. So we have force of x, guideline, sum of forces in the y guideline. To move this now down to here, actually down to here because I like this area better. Now, force of x, let's sum up our x forces. The only ones that go sideways are our force of gravity in the x, which is positive, and our force of friction, which is negative. Okay, force of gravity in the y is only normal force, and then our force of gravity y, which is a minus, not a plus. Force of gravity y. Now, what they also equal is mass times acceleration, just because we know that. And then we also know that mass times acceleration is equal to 0 because there's no y movement going on here because our y is this way, and if there was y movement, it would suddenly fly off or it would sink through the floor, and that's not allowed. So this is equal to 0. This can kind of be crossed out. Now, our ma, we also know that our velocity is constant, which means our acceleration is 0. When our acceleration is equal to 0, everything is equal to 0. So that can also be crossed out. Now we know that these are equations. So if we were to simplify this down now, we have force of gravity x minus force of gravity and then 0. So I'm just going to add this over to the 0. So it equals force of gravity x is equal to force of friction. And then we also have this here. I'm going to do the same exact thing but with different letters this time. So we have a force normal is equal to force of gravity y, just because I added this over. Now we can try to solve for mu. First thing we need here is we need the normal force because normal force is a component of force of friction, and we need to substitute it in first. So just to show that, I'm going to split this up immediately. Force of gravity in the x direction is sine of just the force of gravity because that's what our free body diagram shows us, and that's equal to mu force normal. And now we need to actually find our force of normal. Or normal force. Force of normal. Same thing. So Fn is equal to Fgy. So Fg, and then this is on the close side. So close cos. That's how I remember that one. Theta. Now, this is our normal force. So we substitute this straight into that. Fg, which is also equal to mass gravity sine theta is equal to mu mass gravity, because this also splits up into mass gravity, cosine theta. Now we divide everything to try to isolate mu. We have mg sine theta over mg cosine theta. Now, one thing we know is that the like m's go away, the like g's go away. Now we're left with a sine over a cosine. If you remember from algebra 2 trigonometry, sine of theta divided by cosine of theta is equal to tangent of theta. And then this would be our finished derivation for mu.